Somewhere in the woods of New Jersey, there is a log house that has been standing since 1638, nearly 400 years. It has outlasted empires, wars, and every building trend that came after it. And the reason it is still there has almost nothing to do with the logs. It has everything to do with the stone underneath them. That is the question this video answers. What did pioneer builders understand about stone that we quietly stopped teaching? Log building in North America did not start here. It came over with Scandinavian, German, and Northern Russian immigrants in the 1600s, and those cultures had been combining stone foundations with log upper walls for centuries before they ever saw this continent. When they landed on the East Coast, they brought that system with them intact. The stone underwood formula was not improvised on the frontier. It was a proven inherited technology that crossed the Atlantic in the heads of skilled builders. Here is the first thing that surprises people. Frontier builders were not using stone because it was the only option. In timber country, wood was everywhere. They used stone specifically where failure was unacceptable. The foundation, the hearth, and the chimney. Those 3 points are where fire and moisture attack a wooden building hardest. Stone at those 3 locations was a deliberate engineering decision, not a default. They solved this centuries ago. The question is why we forgot. Let us start at the ground. The standard pioneer foundation was dry stacked stone. No mortar, no concrete, just carefully selected flat stones laid in courses with the gaps left open. To a modern eye that looks unfinished, maybe even sloppy, but those gaps are the entire point. Water drains straight through instead of pooling against the wood above. Frost pressure that would crack a rigid mortared wall just shifts the stone slightly and relieves itself. The foundation was designed to flex and drain, not to seal. That air gap under the floor joists was not an accident either. Frontier builders refused to lay the first log directly on soil. They called it certain failure, and they were right. Soil holds moisture year-round. Wood sitting in constant contact with damp soil rots from the bottom up quietly, invisibly over 5 to 15 years. The stone pier system elevated the entire wooden structure above the splash zone and the ground damp. It created a ventilated crawl space before that term existed. The corner pier layout was also a load management strategy. Builders placed the largest, flattest stones at the 4 corners as primary bearing points, then used smaller infill stones between them. Corners carry the most concentrated load in a rectangular structure. By putting the best stone there, they were directing the weight of the entire building down through the most stable points and into the ground. If the structure settled slightly over decades, it settled at the smaller infill points, not at the load-bearing corners. That is empirical structural engineering. Now, here is the counterintuitive part that most people miss. These builders were not trying to waterproof anything. They were not building a sealed box. They were building a structure that could get wet and then dry out completely. That distinction is everything. A breathable wall that wets and dries survives for centuries. A sealed wall that traps a single moisture intrusion behind a membrane will rot from the inside in under 20 years. The pioneer approach was not primitive. It was a fundamentally different philosophy about how a building should behave. Wide roof overhangs were a critical part of that system. A pioneer cabin roof extended well beyond the wall line specifically to keep rain from running down the face of the logs and pooling at the foundation. Combine that with the elevated stone pier foundation, and you have a building where the wood almost never sees standing water. No chemical preservatives, no pressure treatment, no membrane, just geometry. The roof kept the walls dry, the stone kept the wood off the ground, and ventilation did the rest. The stone chimney and hearth deserve their own section because they were doing two jobs at once. First, they isolated fire from the wooden structure. A properly built stone firebox and chimney mass means the combustion zone is entirely surrounded by non-combustible material. Second, and this is where thermal mass enters the picture, a large stone hearth absorbs enormous amounts of heat during a fire. Once the flames die down, that stone continues radiating gentle warmth for hours. It is a slow-release thermal battery built from local rock. Thermal mass works on a simple physics principle. Dense materials like stone absorb heat slowly and release it slowly. A thick stone wall or hearth does not heat up fast, but it does not cool down fast either. In a climate with wide daily temperature swings, that property smooths out the interior temperature curve. The house does not spike hot during the day or crash cold at night at the same rate as the outside air. This is not insulation. The R value of stone is actually low, but thermal mass and insulation solve different problems, and pioneers were solving the right one. The Nothnagel Log House in Gibbstown, New Jersey, is the oldest known log house in the United States, built somewhere between 1638 and 1643. That puts it at nearly 390 years old as of today. It uses the Northern European system its builders brought from the Old Country. Massive corner joinery, a stone foundation, and a stone hearth. The wood is still there because the stone kept it dry and kept the fire away from the structure. The formula has not changed. The execution is just older than the country itself. By 1810, builders on the northwest coast of North America were already distinguishing between permanent houses and temporary shelters. That word permanent meant something specific. It meant a structure designed for multi-generational use in one of the wettest climates on the continent. In that environment, a misjudged foundation would begin failing within a decade. The decision to build permanently was inseparable from the decision to build with substantial stone or masonry at the base. Permanence was not an aspiration, it was a construction specification. Here's something you can still see today if you walk old homestead clearings. The wood is gone, the roof is gone, the logs have rotted back into the soil over a century or two, but the stone foundations are still there, sitting in the grass, outlining the exact footprint of a cabin that disappeared generations ago. The stone is the last witness. That is not a metaphor. That is a material science demonstration playing out across thousands of abandoned homesteads across North America. Stone wins the long game every time. Now let us talk about the misconception that concrete is just a modern upgrade of what pioneers were doing with stone. It is not. Concrete and dry stack stone fail in completely different ways. A poured concrete wall with no drainage holds water against wood framing like a bathtub. A dry stack stone wall leaks like a sieve, which at ground level in a wet climate is exactly what you want. Swapping stone for concrete without rebuilding the drainage and ventilation philosophy does not give you a more durable foundation. It gives you a faster rotting one. The decline of stone-first thinking followed a predictable economic path. Industrial milling arrived in the mid-1800s. Railroads made dimensional lumber cheap and fast to ship. Balloon framing and then platform framing let builders raise a house in days rather than weeks. Stone was heavy, slow, and required skill. Speed won. By the early 20th century, stone had been demoted from load-bearing wall to decorative veneer. The knowledge of dry stacking and structural masonry did not disappear overnight. It just stopped being taught because the market stopped paying for it. What the pioneer system really represents is holistic thinking about a building as a moisture management system, every element connected to every other element. The wide overhang kept rain off the walls. The stone foundation kept wood off the soil. The ventilated underfloor kept humidity from building up. The stone hearth kept fire contained and provided thermal mass. None of those elements worked in isolation. Remove one and the whole system degrades. That is the engineering insight that got lost when we started optimizing each component separately instead of thinking about how they work together. Before we write it off as primitive, let us look at what actually survived. The Nothnagel house is still standing after nearly 4 centuries. Stone foundations from cabins built in the 1700s are still sitting level in fields across Appalachia and New England. The techniques were not guesses. They were refined over generations across multiple continents before they ever reached North American soil. The builders did not have building codes or engineering degrees. They had something arguably more reliable. They had feedback loops that lasted lifetimes, and they paid attention. If you are working on a property right now and thinking about a foundation, a root cellar, a spring house, or any structure you want to still be standing when your grandchildren are grown, the Pioneer Playbook is worth understanding. Not to copy it exactly, but to understand the principles behind it. Keep wood off the soil, let water drain away from the structure, use thermal mass where you have temperature swings, and build systems that breathe rather than seal. That thinking is not outdated. It is just underused. If this kind of forgotten practical engineering is what you come here for, subscribe and stay close. There is a lot more where this came from.